Today we are going to be talking about, we're going to start talking about graphing. Okay, so we're talking about the x and y axes and coordinates and plotting points. So that's what we're going to be doing for the next 2 months or so. Okay, now the first thing you guys have on your paper is you have a graph here, right? I don't have the graph up here. And you have points on it, correct? All right, so what it says check yourself. Use the given graph. I should say name the point with the given coordinates. So I want you to look at that graph, and you're going to do 1, 2, 3, and 4. You're going to find the point, and then give me the letter that goes along with it. Okay? So this is just review. So you're going to find the point. Start here. 4, 2. Or negative 2. It's yours are, yeah. I don't think I did them though. Okay, Frank, give me the coordinates for B, please. 0, 0. Can anybody tell me what the name of that point is? Nick? Starts with an O. Does that help? R. Dina? Origin. Okay, so that point 0, 0 is what we call the origin. That's important. All right, let's have Vadim. Give me F, please. Negative 4, negative 2. Very good. And Mike. G. Very good. How many people got all 3 of those right? Awesome. Nice job. Okay, good. So that's a little bit of a starter for what we're going to be doing. Today we're going to be talking about different types of graphs and how they relate to real world. Okay? So it requires some reading and some word problems. How many of you bring highlighters with you to class? Nobody? Take one, pass it around. Take a highlighter. We're going to highlight the important parts, right? I gave you guys the graph, correct? And the graph looks something like this, right? What's along my x-axis? What is it labeled? Time. Okay, 9 times out of 10, that x-axis, the horizontal, is going to be labeled time. What's my y-axis? Total distance. And this is vertical. All right, so now we're going to read the paragraph that goes with it and determine what's important here. Okay? So, commute. Let's have Shannon read this for us. Thank you, Shannon. Slowly. Okay, so important things here. Who could think of some important words that we might want to highlight? Yes. School to home is important. Very good. So we're going to highlight school to home because that's the path that he's going. You're going to do this too, Mr. Smith. Yes, you may. Sorry, I forgot to give you one. Yes, Shannon. One student, we're okay. It's not overly important. We know that he's going somewhere because he's already going school to home. Frank? Each day. Okay, so this is going to represent one day. And the other things that are important is we've got time and distance. Now, had they not labeled the axes for us, we should have been able to say, okay, I know we're going to use time and distance for my axes. So those two are very important. Okay? All right, so now we're going to talk about how our graph is actually changing. What's happening is, if he's starting at school and he's going home, right? So this is the start of our graph. We're going to put a 0 there. There's already a 0 there? Okay, and that's going to represent Where is he? When he's just starting? He's at school. Because he's going from school to home. So he's starting at school, right? Okay, he's walking and taking a bus. That's also important. So highlight that as well. Walking and taking a bus. And you're going to see why that's important in just a second. All right, so he's at school. What's going on here is time is moving and he's getting further away from school because our distance is increasing. So time is going on and he's getting away from school. So here we're going to say he's walking to the bus. Okay? So time is moving, distance is moving. He's walking to the bus. Notice our slope isn't very steep, so he's not walking too fast. Okay, but what's happening here? Time's moving. Is distance moving? No. So what's happening, Maria? He's waiting. So he must be waiting for the bus. Okay, so he's walking to the bus. He's waiting for the bus. What usually happens after you wait for the bus? Yeah, you ride the bus. So you're riding the bus. And notice how steep that slope is. Why do you think this is steeper than this? Not going uphill. We're thinking time and distance. What? The bus is driving faster than he was walking. So this has got to be steeper than this. Good. Okay, so notice we still have a little bit of an incline here. We rode the bus, but now we're going a lot slower. We're still moving, but we're going a lot slower. What's going on? We're going from school to home. Yeah, so he's walking from the bus stop to his house. So walk to house. So you should have all those parts labeled on that graph. Did I give you the axes on this one? I did? Okay, so time is along the x. Distance from home is along the y. I want you to read the problem and highlight the important parts, please. Dina, tell me what you highlighted, please. Home to school and back. Good. What else is important? Walking and getting a ride. Good. Nice job. Walking from home to school and back, and he's walking and getting a ride. Okay, Nick. Nick, where's he starting? Where's he starting? He's starting from home. Good. So he's starting from home. Good. He's walking and getting a ride from a neighbor. All right, so think about it, what you would be doing if you were walking and getting a ride from a neighbor to school. Carly? He's starting at home. What do you think's happening here? He's walking and getting a ride from school, from his neighbor, to school for his neighbor. He's walking. Where do you think he's walking to? Good, walking to neighbors. Okay, walking to neighbor. Cameron? After he walks to his neighbor, what's happening? He gets to the car. Okay, now look what's happening here. Is time moving? Time? Is time moving? Time moving? But distance not. So, is he going anywhere? So what is he doing here? Yeah, sitting in car waiting. You could just put waiting. So he's waiting here. All right, Shelby. What's going on here? Car is moving, so driving to school. And how do we know that's driving and not walking compared to this? Because the slope is steeper. We're going faster, right? Nick, I got you again. Sorry. All right. What's going on? At school. Good. Time is moving, but we are not. Maria. Driving home. Good. Driving home. Cameron. Driving home. What's happening here? Careful. Time's moving. Distance isn't. Yeah, so he's waiting again. Maybe he's talking to his neighbor. Mr. Smith. Last piece. Walks home. Good. How do we do with that one? Pretty well? We like these? Yeah. Good, I'm glad. Yes, we're going to do that next. Okay, so turn to the next page. All right, so these ones we have to draw for ourselves, right? Travel. A plane is flying from New York to London. Sketch a graph of the plane's altitude during the flight. Label each section. What's altitude? Height. Yeah, it's height in the sky. What's your question, Shannon? Well, this time instead of distance, we're going to use, good. So Brandon, can you tell me what goes along the bottom? Time, good. This is our x-axis. Time goes along the x. That's our horizontal. Mr. Smith, please tell me what goes along the y. Give me another word for height. Altitude. It's like attitude, but with an L. Okay, so now I want to sketch a graph of what might be happening during this flight, right? So think about how you get in a plane, right? Altitude, you're starting where? Starting on the ground. So here's the ground right here. Starting on the ground. Are you automatically going to shoot up in the air? No. So what's going to happen to your altitude? It's going to gradually get higher. And when you're in a plane, do you just keep going up forever? What's going to happen? You're going to eventually stop going high. Are you going to stay up forever? You're going to come back down. A lot of times you have to circle around, so maybe you'll stay steady again, and eventually you'll come down. A lot of times they have to circle around before they land, so they don't land on top of another plane. Okay, so that's an example of what might happen for a plane. Now I want you to take that picture and label it accordingly. What's happening? Okay, Mr. Maury, what am I doing right here?
The plane starts to go higher.
Starts to go higher, so I'm taking off, right?
Yeah.
Vadim, what's happening here? Say it again? Yeah, we're flying, and we're staying steady, right? We're not dropping, we're not ascending, we're not descending, we're staying at the same height, the same altitude. If you'd like. Frank, what am I doing? Gradually coming down, so descending. You guys heard the word descending before? No? That's not descending your arm. Extending. Dina, what's happening here? Yep, we're staying straight. So maybe we're circling here, staying steady. Do they make you pay overtime if you're in the plane longer than you expected? No, they don't.
Could you put like that 4 periods? Right? Oh, wait.
Yeah. Okay, Carly, what's happening here? Landing. Good. How'd we do? Pretty well? Okay, now, the next one you guys are going to do, you're going to try it on your own. So you want to graph the distance from a child's feet to the ground when they jump rope. So what happens when you jump rope? So distance from the ground. I'm going up and down. Am I ever staying steady in the air, floating? And then what happens? Okay, so I want you to show a graph of a child jumping rope over and over again. You don't just jump once, okay? So show me the pattern. So go ahead and give it a shot. Want to come up and draw it? Horizontal, you told me, was distance. Vertical is time. Okay, now there's a couple different ways you could do this. You could do a nice curve, or you could do a nice point. Okay, because really, are you staying up in the air that long? You're going up, you're coming right back down. Okay, so they should be nice and short, up and down real quick. We okay with that? I don't expect them to be perfect. I just want you to see, I want to see that you understand how you could graph an event. Okay? All right. You guys have 4 graphs here, correct? Okay, so this is multiple choice. All right, so the question says, suppose you pour water into a container at a steady rate. Steady means what? Yeah, kind of like the same amount at each second. Okay. Which graph shows the change in the height of the liquid in the container over time? So you're pouring water into a container. What's happening to the water level? Carly, what do you got? Steady, 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 steady. You want it in a steady rate. C. It's going to be choice C. That's the only one that's going steady. We don't have any dips or curves. Circle it. Doesn't matter. Okay, the last one is also multiple choice. We have choices F, G, H, and I, but I did not give you the graph. I apologize, so I'm going to give you the graph now. Draw the graph in, please. So this is distance. C. This is time. So I'm going to give you the graph, and I want you to tell me which one of these scenarios, F, G, H, or I, goes along with that graph. So take a second, think about it, and pick the right one. My options are a car traveling at a steady speed, a cyclist slowing down and speeding up, a train slowing down, or a plane accelerating and then taking off. What do you think? F. Good. F is your answer. Okay? How many of you brought your textbooks? Mr. Grippy. Hey, Mr. Grippy, can you tell me what is going on at the flat sections of this graph? The car is keeping a steady pace. Very good. So the speedometer is not changing. You're going the same speed at these flat pieces here. Okay, so your speed is not changing. How do you know if you're stopping? Where are you stopping, Mr. Maury? When the speed goes down to 0. So we're stopping here and here. So we know that that's stopping because my speed becomes 0. All right, so now I want decreasing. Shannon, where am I decreasing? What?
Waiting and have a comma, speed stops, time goes on.
Your speed doesn't stop. And you're not waiting. You're still moving. You're just staying at a steady rate. Shelby, where am I slowing down? Where's my speed decreasing? Good. So I'm decreasing in 2 places. And notice when I'm decreasing to a stop. My speed is going to 0. Does that make sense? Okay, so let's look at the next one. Put down my pen. Okay, the graph shows the relationship between time and distance from home. So what you're going to do is you're going to answer 3, 4, and 5. So I want you to take a couple minutes and answer those 3 questions. We'll go over them in a second. Mr. Smith, can you please tell me what the flat parts of the graph represent? Now be careful. This is distance from home, and this is time. Time is moving. Is distance moving? So are we moving? Okay, so the biker is doing what? The biker has stopped. That's fine. So the biker has stopped. Okay, good. That's for the last one. That's when we were talking about speed. Now we're talking about distance from home. Got to make sure you read the axes. That's why that's important. Mr. Grippy, can you tell me what's happening from 3 p.m. to 4 p.m. and 5 p.m. to 6 p.m.? Good. The biker is getting closer to home. Excellent. Thank you, Frank. Cameron, what does the section from 12 to 1 represent? Riding his bike where? Where's he going?
Home.
Is he going home?
That was farther from home.
He's going away from home. Good. So the biker is going away from home. To the store. That's where he's going. Okay, good. All right, how are we doing with these graphs? Pretty well? It's reading graphs, Shannon. Has everything to do with math, my dear.
That's that, right?
Yes. It'll video record it on here. Okay, so just do it right over there. Okay, so number 6, Tim. Number 6 is going up on the board. Okay? Then I'll pick somebody else to do 7. Yes. Okay, so it's fine. It's okay. Elevation from sea level. When you're hiking a mountain, you're going to increase your elevation. Eventually, you're going to have to come back down to the ground. So that's fine. Good. No, it just means you never came down off the mountain. Maybe you got lost up there, froze. If you never came down, yes.
I would get lost.
Okay, 7. I'm going to have. Did I say you? I'm going to have Tim do 7 for me, please. So he put time and distance. Now we're talking about number 7. Do I want to use distance? I want to use speed. And what other thing do I want to make sure that I have? I'm going to nail you on for not having.
Oh, you're starting to Oh, no. Your arrow. I like that.
Okay. So he sped up, stayed at a steady speed, and then he slowed down when he got home. Okay? Good. All right, number 8. Somebody else. Mr. Murray, go ahead and do number 8. Okay, so he has the height of the airplane above ground flying from Dallas, Texas to Atlanta to Georgia. Height. That'll work. Very quickly. So she's stopping at 2 spotlights, so her speed's going down to 0. Good, nice job. Okay, homework tonight, lesson 54, 45, sorry, I suppose. Lesson 45, it's in the note packet. There's 3 questions. It's very short. I expect it to be done. I will check it next class. You will stay in your seats. Nope, you will stay in your seats until the bell rings. You can put your calculators away when the bell rings. So please stay. Sit. I just got done saying it. Stay in your seats until the bell rings. When the bell rings, you can put your calculator away. Sit.